Hello everyone, welcome back. So in this lecture we are going to learn ASBITSTREAM function in ESQL. Before the ASBITSTREAM function, earlier it was known as a bitstream function. So before AS word was not there, only bitstream. It was known as a bitstream. Later the bitstream function has been removed from the operation, and bitstream function has replaced with the as bitstream. So you can just remember as means as. So it is as similar to the bitstream function. So why it has been removed? The reason is that the bitstream function has some limitation that we can overcome with the help of as bitstream function. Okay, so that's an IBM has remove the bitstream function, replace the bitstream function with the as bitstream function. Okay, so that's the one point you need to remember. Before understanding the as bitstream function, we should have at least basic knowledge of encoding and the coded character set identifier, also known as CCSID. Okay, so first we will learn encoding. Then what is encoding, a basic of encoding, type of encoding. After that we will learn what is CCSID and why CCSID is important. After that we will understand what's the difference between the binary data and the hexadecimal data. And at last we will understand the what is the use of ASBITSTREAM function in ESQL and why it is so important. And before that, let's me go to the toolkit directly, and let me explain you a situation. Suppose let's take the flow that what I already prepared for the ASBITSTREAM function. Later I will be explaining you. Let's suppose there is a simple flow I have. In this simple flow, what is happening? Business is sending an input XML message. Correct? In that input XML message, there can be two possibility. It will go, if it will be a successful, it will go to the MQ output, and if in case of error happen, it will go to the MQ output exception queue. Okay, but there can be a possibility that business will ask to keep a whatever the message we are sending to output, keep a copy of payload into the database, and whatever the error we are sending to output, we can to keep a copy of payload into the database, right? So there can be possibility whatever the input message we are sending into XML format. Okay, business will raise a concern. Okay, just send the message to MQ output, we are happy, but we want a copy of payload to save into database, and also I want to keep a copy of what error occurred and at what time it occurred into database, so that we have a record of payload and what error happened in for the future. Correct? But now here situation happen like that. Suppose the XML message are so large, and business normally sends a message of 100 line, 200 line, 500 line, 1000 line. Even I have seen the message with a 1 lakhs line. Okay, so those large message, if we are going to insert into database, it will take a huge memory, and my database storage is going to be fill up, and that's a big concern for the database team, right? So that's the one situation happen where database team said that we cannot insert the payload because it is taking the huge space. and we cannot capture, we cannot store the error detail because it is also taking a huge space. So what we can do, we can suggest database stream. Okay, you are correct because it is taking a huge space, but we have a solution for you. So what's the solution for you? We have a solution where we can do one thing. We can whatever the input message, business sending into XML format, we can convert it into the binary format into bit stream, and you can store that message. And further, when it needs to when it needs to look into data, we will use the encoding to read that message. Ideally, binary data is a combination of 0 and 1, and we cannot read without without using a special tool. Okay, by the normal human eye, we cannot understand the binary data. To understand the binary data, we need some extra tool to convert into the hexadecimal. Okay, so we have given a proposal to database team that, okay, I know your concern. Your concern is that when when we are sending the data into database, it is taking a huge space, and your database is going to be storage is going to fill. To overcome your solution, we have come with a solution that we are not going to send you a whole XML message. We are going to send you a XML message into the binary format, into a bit stream format. Okay, and that is going to take a very minimum space because that is the raw data. Okay, so then after that, when you will say this to the database team, they will become happy. Okay, now we are happy. We can insert your payload and insert your the what I said, insert into your what I say that insert your error details into the database. So that's the thing. How can we convert our input XML message payload into the bit stream? We are going to see in this lecture. How can we convert the error detail we are seeing into the bit stream message? We are going to see this thing also. And how can we convert uh, how can we insert these all detail into database? We can see this. We are going to see in this also. Let me show you. Already I have something inserted there. So let me show you. If you see here, if I will this is a table I created where the table name is order underscore payload. That's table I am going to use. Further I am going to show you to insert into the insert the payload. So you can see, if I will just show you, if I will select the table, you can see this table having the two column. First column is called the payload, and the second column is called the payload when it is inserted. Okay, and if you see these all details, it is only coming as a binary data, but we cannot see what is the data, because binary data is not understandable by the human. It cannot be understood. We need to encode the binary data to understand it. So finally, another I have written another syntax to encode the binary data. So let me execute this command. When I will execute this command, now you can see whatever the data I have sent, this all data is now encoded into the hexadecimal format. Okay, and now we can understand it proper way. Further, if you want to do in convert encoding this hexadecimal value into the some to check into the convert it, you can convert into ASCII format to see what actual data sent into the XML thing. Okay, so in this way, similarly, for the error detail, you can see for the error detail also you can see the what error happened. I have created a table with name what I say that with name is error db, and you can see all the error detail I am inserting here. Okay, So this is how can we insert these all detail, and this binary data is basically takes a very minimum space for database, so that basically help the DBA team to make operational without losing the lots of storage space. So that's the thing we are going to achieve in this lecture. So if I say in one line what I am going to achieve, we are going to send a MQ input message into the XML format, or you can send into the any format JSON, that's not problem. But here I will be showing you only one format as XML format. You can try with JSON, and if you are still facing a challenge, you can reach out to me. Okay, I am saying I will be sending into JSON format, XML format. Further, I will be taking two situations. First situation where I am sending a copy of message to MQ output. Second, parallelly sending message to MQ output. What I am going to do, I am going to insert a payload into the database order underscore payload into the bit stream format. Okay. Further, if in case of error happen, what I am going to do, I am going to capture the error detail, and further I am going to do insert into the table is error db into the bit stream format, and further into the binary data, and and also I want to send a copy of error detail to output, so that the people support people who is working into the project, they can get the error detail, and they can see what actually they can do to modify the thing and to make the business operational. Okay, so that's all thing we are going to learn in this lecture. But before understanding the what is the bit stream, what is the ASBIT stream, what is the binary data, it is very important to understand the encoding and the CCSID, because encoding and CCSID came into a important picture when we are using the binary data and these all things. Okay, so let's go and understand the basic of the encoding and the CCSID. So first we are going to learn the encoding, then CCSID, and then I will be coming to the ASBITSTREAM. When talking about the encoding, encoding is the process of transforming a data from one format to another format. Suppose I want to transform a data into a XML to the binary data. I want to convert a XML message into the binary data, or a picture. I want to send a picture into the to some other place. So I want to just convert the picture. We will basically converting the it into the binary data. Okay. So with the help of encoding, we can do some transformation from the one format to another format. The main purpose of encoding is to make the data suitable for the specific purpose like storage, transmission, and security. Okay, so don't worry regarding the why it is why security and transmission and storage is important in term of encoding. We are going to learn here. I will be reaching to here later. Okay, so you need to just remember the thing, you understand the thing. So encoding is important to make data suitable for the purpose like storage, transmission, and security. Now let's understand the situation. You know the thing very well, and you have also learned in your earlier classes of college or schooling. Computer does not understand what we write on the normal with the normal keyboard, right? In normal keyboard we write some English language, but computer does not understand the English language. Computer only understand the in a computer only understand the things into the 0 and 1, right? This This is the basic definition. I hope you all have learnt into the uh, third or fourth class of the schooling. Okay, so that's the very thing, that's the correct thing also. Okay, so we all know that computer does not understand the English language what we type of from the keyboard. They can only, a computer can only understand the 0 and 1, that is called the binary data. So whatever we type basically on the keyboard, that basically got converted into the 0 and 1. And further, if output sent by the if the computer sends the output, computer sends the output in form of 0 1, but we have the some interpreter like the thing that basically converts the 0 1 into the into the English language so that user can understand, and that's the bridge can fill between the computer and the human, and that's all can be achieved with the help of encoding. So in the computing world, encoding is crucial because computer communicates in the binary 1 0 and 1, but we often need to work with the human readable format like the text, image or file, and encoding bridge that gap. That's I am saying. So if if the human wants to communicate with the computer, or computer wants to communicate with the human, then we need the encoding to make it possible. The encoding fills the bridge between the human and the computer. Now let's understand why encoding is so important. I will be discussing 3 points: the why in terms of storage, transmission and security. When talking about storage, some type of data need to be stored in a way that save the space or it is easy to handle. Okay, for example, the text file often need encoding to make sure the character are represented correctly. So encoding is important also in term of storage. If you remember, few minutes back I have given example where I am doing encoding into the binary format because I want because storage team is not ready to capture the whole input message into the XML format because of the size of the message. They want to us to convert the message into the binary format with the help of encoding. Okay, and and after that they are basically ready to insert. So with the help of encoding we can achieve the targets where we can save the space, we can save some space, and we can easily handle the things and make the thing easier. So that's the same thing it is written here, is some type of data need to be stored in a way that save the space. So like our case where we are inserting our data into database, XML data into database, but we cannot directly insert the data into database. So we are basically doing first converting to binary and then doing the insert. Now takes the second case where transmission. When sending data over the internet, like where over the network like internet, encoding help to ensure that the data does not get corrupted during the transmission. So you know that the data is now a one of the important thing, and the whole world is working on data itself, right? So whole world is working on the data itself. So when talking about the thing, data came into one of the important picture, right? Now to make sure the data transmitted successfully without any getting corrupted, we need the encoding. The encoding help us to ensure that The data what we are sending over the internet, it is not going to corrupt, it is not going to destroy, it is not going to modify, or it is not going to lost. Okay, that's the one thing why we need the encoding. Now let's understand this in terms of security. Some encoding methods are used to protect the sensitive data and make it harder for the unauthorized people to understand. Sometimes we use the encoding to make the things secret. Suppose there are a URL we are basically using to hit it, but if we use the if we hit the normal URL, it is more readable. But if we encode that URL and give the user to use it, then user will not going to understand what exactly that URL do, right? That basically increase the security, because URL is a combination of what parameters, like that the URI parameter or some parameter. Basically we combine that parameter and make a proper URL, and we basically hit a web service. But if we give that URL as it is to the user, they can understand what exactly doing, and they can maybe harm our business. But if we encode that URL, business will not going to understand, and they will just blindly hit the thing. Okay, so that basically protect the unauthorized people to understand the thing. This is one of the example, but there can be a many example possible where encoding is so important. Okay, now that's the basic about the encoding. Now let's understand the types of encoding. When talking about the types of encoding, there are many types of encoding, but I will be discussing few type of encoding that are very important in term of ACE and also in term of the generic thing. So I will be only discussing 4 type of encoding, and that is really important. First is coding. When talking about the encoding, during the initial days, only ASCII encoding was launched. ASCII. This is the encoding type. This is the what is the use of the encoding, and these are few example I have written here. Okay. So initial days, ASCII encoding was first invented, and with the help of ASCII encoding, simple text character, especially the English language, whatever I am writing in the English, I am writing on the English on the computer keyboard, that basically we are converting with the help of ASCII encoding, and it uses the 7 bit to represent each character. So for each character, like here A, it only uses the 7 bit of memory. But there is a one problem happened with the ASCII. It only allow 128 character in this encoding. So in this encoding, ASCII encoding, only 128 character, including the alphabet and numeric and some apart from that some syntax. It all total includes 128 character that was allowed for the encoding. Okay, so ASCII is a encoding that basically help us to encode the English character, especially the English character, and it use the 7 bit of memory for the each character, and it only allow up to 128 character. And suppose their example, if you want to encode A, so A basically in encoding it is represented by 65. To encode A, we computer understands we basically when we encode A, it will be 65. Okay, Now further the challenge, what challenge happened in, in the world, not only the English language is there. In China, the Chinese language is spoken. In French, the French language is there. In Germany, there is some other Germany language is there. Okay, so in the different part of the world, there are different language, right? And that basically this ASCII encoding fails. So this ASCII encoding got failed to encode the character that is not English. Okay, to overcome this situation, another encoding type is launched, that is the UTF-8. This UTF-8 is the helping to representing the multilingual text. So if it supports the almost all language, whatever the all language standard language is present in the world, including the Chinese, German and the French, these all things, this all language has been included under the UTF-8 encoding. And apart from that, all the whatever the 128 character was in the ASCII, which all thing has been included into the UTF-8. So it is the backward compatible with the ASCII. So whatever the thing ASCII was doing, this all thing it can do, and apart from that, it can do the some extra thing encoding, and it uses the 1 to 4 byte per character. So there is no fixed character, like here it uses the 7 bit for the each character. Here there is no fixed byte, what how much it can consume, memory will take. So it can vary, it can take 1 to 4 byte of memory per character. For example, if you see, if we will encode A, so it will be on 65, but if we will this character, it will be 233. This is not a English, this is some other language, where you can see on the top of E there is a apostrophe s. Okay, so this is the English character, but this is not a English character. So here I have tried to show you two example with one English letter and another is not English letter. And currently, when talking about the encoding, this is the one of the best encoding, and the people are, most of the industry I am seeing that this encoding it is being used. Okay, now coming to the next is the base 64 encoding. This encoding has been launched by seeing the thing, suppose in the industry. So when talking about the base 64 encoding, so this encoding has been launched by seeing the situation where, so when situation came to do encoding for the image, video or the files, suppose I need to send a image over the email attachment, right? So we cannot send directly image without attachment or some file without attachment, right? Suppose I need to send a PDF file. So this PDF file without attachment we cannot send, right? We have the only one way to do the attach the PDF into the mail and send to the recipient or receiver. So you understand how basically this all transmission of the this PDF how basically happens. We basically mainly see that this all happen normally, but this does not happen normally. This all happen due to the encoding that is set in the background, and that is the base 64 encoding. So base 64 encoding is the binary data like the image, video or files to send it as a text. Example, the email excitement. Base 64 encoding converts this binary data into the ASCII text, okay, and make it easier to send the email as a email attachment. So base 64 encoding basically what it does. So these all, whatever we sending, the image, video, or the file, these are also called as a binary data. If you want to send a binary data over the email attachment or whatever thing, so we use the base 64 encoding. And that base 64 encoding basically what does, it converts the binary data into the first into the ASCII format, so that it is easy to understand the thing, and as a email attachment, and it is always it is easy to send the thing. It is easy to send the image as a email attachment. Here is a simple example I have taken. So if you want to do the base 64 encoding for the hello world, so it will look like that. Okay. Now let's go to the URL encoding. When talking about the URL encoding, as name suggests, the URL, so it is used for the encode the URL that I have already explained you in the beginning, so that people will not understand what basically my URL does the work. So we can encode the URL with some special character, and that URL I can give to the user to execute that, and URL will not understand, user will not understand with that URL. That's simple. You can see here hello world is encoded with hello %20 world, where a space has been removed with %20. So in this way, this is a very simple thing, but this can be a URL where it can be encoded and people will not going to understand the thing. Okay. So this is all about the encoding in the, what is encoding and why encoding is important, and what all are the type of encoding. So if I say that encoding, in short, encoding is a process for transforming a data from one format to another format, and it is used for the transmission purpose and the security purpose and the storage. And when talking about the types, so the most important are the four types. ASCII is for the simple English character, and it only supports 128 character. Further, it is the UTF-8, which is the used for the multilingual text, and it almost support all the character. Further, with the base 64, if you want to encode the binary data like the image, video, and files, for that URL encoding, if you want to encode the URL. Now let's understand the next is the uh, CCSID. When talking about the CCSID, that is the also called as the coded character set identifier. This is one of the important when we are learning the doing the encoding, because encoding is not enough without the CCSID. When talking about uh, especially when talking about the UTF-8 and the ASCII, because these are for the character thing. Okay, so when talking about the character encoding, then a further division came to the CCSID. So you can say that it is a what I said, that it is a division of the encoding with the CCSID. You can say that, because we cannot explain, we cannot do much thing with the encoding, character encoding. So further, it has been given like that options. So this type of language we can do with the this CCSID, this type of language we can do with the this CCSID, this type of language we can do with this type of CCSID. Okay, so further character has been elaborated. So how basically you want to do encoding, that's so you can say that encoding, character encoding is a part of CCSID, you can say that. Okay, so without CCSID, character encoding is not much effective. Okay, CCSID is a numeric value that uniquely identifies a specific character set and encoding scheme. Okay, so it is saying that CCSID, what is CCSID? CCSID a numeric value. You can see here a few example given 273, 819 and 1200 and 1208. So this CCSID is just a numeric value that basically represent the CCSID, and that basically uniquely identify a special character set and encoding schema. So in simples, I say what is CCSID? CCSID is a numeric value that basically allowing few of the character to do encoding. You know that there are because under the UTF-8 all the thing are allowed, right? All the thing are allowed, but there can be further division where I want only to English language to allow. Okay, so I want only German language to allow. I want only Latin language to allow. So this all further division happen with the help of CCSID. So with the help of CCSID, we can restrict these all thing. Okay, I want only Latin language. I want only German language. So these all I want only US language. Okay, so these all thing can be achieved with the help of CCSID. Okay. In simple term, if I say that it tells the computer system how to interpret the byte of data it receives so that the text is displayed correctly. Okay, so that already told you. So it is nothing how many we are typing the letters over the keyboard. It basically saying the computer, okay, whatever the thing we are saying, whatever the thing we are typing over the keyboard, all the things, how my computer is going to interpret it, this all each can be achieved with the help of encoding and CCSID. Okay, so a CCSID determines which character encoding schema is used. Okay, so with the help of, you know, I already told you that CCSID is nothing. When we are using the ASCII or UTF-8, then we have to understand the CCSID. Okay, the CCSID is the only thing which basically determines which character encoding we are going to use. We are going to use the ASCII, or we are going to use the UTF-8, or you are going to use the EBC DIC. Okay, few of the common encoding that are very important I have listed here. Although there are lots of encoding, there is a big list. Okay, you can go over the internet and you can search, but most common use are these four encoding that I have listed here, and from among those all, this 1208 is the most used, and this is widely used in the IT industry. Okay, when talking about the CCSID 273, this is especially used for the German language. So if you want to do encoding and if you want to allow only German characters, so you can specify the CCSID 273 in the encoding. Okay, now if you want to, when talking about the 819 represents the ISO 88591, this Latin one, encoding for the Western European language. Okay, so this is the CCSID 819 basically represent mostly for the Latin language, like the French, English, German, these all thing. Okay, so this covers the this encoding 819 almost cover the many language, not only the English language. It covers the almost whatever the Latin language, what are the language is spoken at the Latin side of the world. These all language has been included under the 819. So if you are thinking that my business is limited to use the language that is under the Latin, then you can use the encoding 819. Okay, so if you have a message in English that uses a Latin character, then 819 is the common CCSID for the encoding that message. Okay, that's the same thing I have told. If you are thinking that my business is not going to use outside the Latin language, then you can use the 819. That is enough for the CCSID encoding. Okay. Now talking about the CCSID 1200. This is called the UTF-16 also. Sometimes it is called as UTF-16. This is also unique, another Unicode standard. This basically launched, I think, after the 1208. Okay, so this is something that I think enhanced version of the 1208. But you can learn about the 1208. I don't have much detailed explanation on this thing, but this is one of the encoding where the vast level of the thing included, vast level of the language included, and it is almost covering max to max language under this. Okay, now coming to the 1208 encoding CCSID. Okay, so when talking about the 1208 CCSID, character coded character set identifier, it is also called as a UTF-8 encoding. You can see this is called as UTF-16 encoding, CCSID 1200, but 1208 is called as a UTF-8 encoding. Okay, and it is widely used encoding that can represent any character in the Unicode standard. That's already look. This is the one of the encoding of the CCSID. It covers almost all language of the world, and if you are thinking that my business can use any language and my business is spread all over the world, so you don't need to worry. You can blindly use the CCSID 1208, that basically going to parse the any character that you want to encode. Okay, so suppose if you are sending data containing some special character like the Chinese character or some Japanese character, then in CCSID 1208 will ensure that the UTF-8 encoding is used and allowing the character to be correctly encoded and decoded across the system. Okay, so with the help of 1208, you will make sure the business that you can send any character and I am going to do encoding. I am going to correctly interpret it, and it is not going to modify the data, and it is data will be not going to hamper. Okay, so this is all about the CCSID. So in simple and term, if in layman language, if I say that CCSID is a you can say that when talking about the ASCII and the UTF-8, it is a sub part of, you can say that, encoding. When you are learning the character encoding, CCS encoding comes into the picture, and CCS ID basically tells that which character we are going to allow and which character we are not going to allow to send to pass the message to, when the business will send a message, which character I will be going to allow to parse it and which character I am going to not allow to parse this. That can be achieved with the help of uh, CCSID. So CCSID is the only thing which basically determines which character encoding is going to use, either ASCII or UTF-8 or some other encoding that is going to use. And commonly used are the 12 273 for the German and 819 for the Latin language, and 1208 for the all the language. If you don't know any language that beyond the business, and if his business is saying language some like Chinese and Japanese. Okay, so these all language is going to be encoded with the help of CCS ID 1208, and that basically going to allow the character to be encode and decode across the system. Okay, so now that's we all learn about the what is encoding and what is CCS ID, and I hope you have understand it the very well, right? Now let's understand the what is ASBITSTREAM. So we have understand the encoding and why encoding is important and what types of encoding. We have understand the what is character codes CCSID and what is the uh, types of CCSID and not types of CCSID. It is the few examples of CCSID. Okay. Now let's understand the ASBITSTREAM function that we are going to use in the ESQL and how it is important and why basically it is we are going to learn. The ASBITSTREAM function in the IBM is it is the built-in function used to convert a message or data from one format to a bit stream format, that is the binary or raw byte data. So point number one, if you are using a bit stream function, it is used to convert any data, whether it is a XML data or whether it is a JSON data or whether it is some other text data. It can convert that data into the bit stream data, bit stream format. On in bit stream is the some technical language, you can say that. In simple we can say, you can understand it is a binary data, or it is also called as a raw data. So ASBITSTREAM function converts any format into the bitstream format. Second thing, it is also used to convert the structured message data like XML, JSON or message in a specific character encoding into the unstructured binary data format. Okay. So let's take an example. Suppose you can see here this XML message. This is the XML message. Where is the XML message? Okay. You can see this is the XML message, right? There is a one error I have captured here. Okay. So this is the error I have captured here. And this you can see this is the representation in form of XML. When we will do the ASBITSTREAM function, it is going to encode into the, it is going to convert into the uh, binary data, but we cannot read the binary data by the human eye. So to read the binary data, what we can do, we can convert the binary data into the hexadecimal format, and that's the representation of hexadecimal thing. Okay, so that is basically how the it will look into the hexadecimal. So it is like that. Okay, it can be seen into the one line. I have used the word wrap, that's the reason it was looking like that. Okay, so if I will do like that, so you can see it is in this form. Okay, so this is looking into one line. Okay, so this can be easily inserted into database. This it can be easily inserted in database because it is in the one line format. Okay, so now you can see how basically this 76 line of XML format converted into the hexadecimal with one line of encode with the help of ASBITSTREAM. Further, if you want this XML message to convert into the, what I say that, into the XML language, not like exactly like that, into the string, you can see this is a string, right? If it is not into the some XML exact XML format, it is in form of string. Okay, so if I will remove the word wrap, it can be a one line. You can see it can be become a particular one string, if right. So XML, we can store the XML into form of string also. Okay, so that's all we can do with the help of ASBITSTREAM function. Okay, so we can convert this XML format into the this, and this XML format into the this format. Okay, this norm into the string format. This all we can, I'm going to see how can we do the thing. Okay, so So that's, you can see, this is how this is so structured, right? This is a structured format, right? Where we can see under the parser we have the file, further under the second parser we have the this file lines. So this is a structured method where we can read the information easily, right? So when we have a XML message, when we have a JSON message, those messages are called a structured message, where information can be easily be we can read the information easily, we can interpret the information easily, we can navigate with the help of tree the information, right? But when we convert this information into form of binary data or hexadecimal format, this will become the raw data, or it cannot be read normally by the human eye. You can see it is some combination of alphabet and letter, right? So this will become the unstructured data. So here what I'm doing, I'm converting the structured data into the in form of unstructured data. Okay, so that's the same thing it is saying here. Okay, so with the help of ASBITSTREAM function, what we are doing, we are converting the structured message data like the XML, JSON into the unstructured binary format, and allowing it to be transferred, stored, or the further process as a raw data. So this basically helping us to store into our database, or further suppose there is a Google website, okay, or suppose there is a Amazon Kinesis, okay. So Amazon Kinesis is also a Amazon tool where we can store some data. Similarly, Google has a some pub sub concept where we can store some data, okay. So suppose I want to with the help of IBM, is I want to send the data to Amazon Kinesis, okay. So Amazon Kinesis can store the data into their with the help of Kinesis stream, okay. So these all thing can be stored, but when we will send the normal XML message, it will be a very large data for them, and their system will going to take a more storage thing. So it will become complex to do transformation. Point number one. So in that case, what we are going to do, we are going to convert into the unstructured format like that binary format, and we are going to transfer it to the Google or the Amazon, and it is going to the insert into their Kinesis stream. Let's take another situation where suppose there is a XML with 1 lakhs line, okay, or 100k line, sorry, 100k line, okay, or 98k line, okay. So that XML message, when you will be going to send to the ACE application, and when ACE application is going to navigate that XML, suppose a source application is sending XML with 100k line, and that XML message I need to transfer it to the destination with the help of ACE application, and that is only my job, okay. But what's the problem is that, or there is, suppose there is a source is sending a message into XML format which is of 100k line, and my job is to transfer the message to the into the consumer application, but with different formats. If source is sending to XML, I will be going to send it to JSON, and if just source is sending to JSON, I will be going to send it to XML format, okay. So this is type of situation. So if we will allow the whole XML message with the 100k line, our application performance is going to degrade, because it is going to parse the large data, and when our application need to parse a large data, then it will basically take some time, and taking some time by application, it means application performance is going to degrade when the load will be high, right? To overcome this situation, what we can do, we can convert, we can with the help of ASBITSTREAM function, what we can do, we can we can first convert this XML message into the bit stream. Further, this bit stream message we are going to convert into the this type of XML message into the one line, and this will become like a string, and it is not going to take some it is not going to create a logical tree, and this message we can easily send to the destination application. Or what we can do, we can say, we can told the source application to send the data into the some we can use some parsing as a blob. So source will send a message into the XML format, but we can use here as a blob format into the XML parsing as a blob, and we will take a blob message, and further with the help of casting we can do the casting and the encoding, CCSID encoding, we can convert the data to string format, and this string format is not going to navigate the logical tree because it is just like a string message. So it will become easy to parse, and my application performance is going to increase. Okay, so that's all situation you need to imagine. I cannot explain all the situation because here is some restriction I have, so with the time, so I cannot go through the all the cases. I know I'm not going to show the all the possible cases because this all possible cases is only possible to practice the thing. So I cannot explain all the use cases. So these all use cases I'm actually saying, and you can try with yourself. Okay, and if you are still facing some issue, you can reach out to me. I will try to expend some time for you. Okay, so this all situation can be possible where we need to transform the XML message into the bit stream message, or XML message into some or we can say that some bit stream message into the string format. So this all situation happen where we can convert a XML message into the bit stream or hexadecimal message, and the hexadecimal message into the string format, so that it is easy to transform between the system without degrading the application performance. Now let's understand about the benefits of using the ASBITSTREAM function. When talking about the benefits of ASBITSTREAM function, there are two benefits I have mentioned here, although there are many benefits. But I thinks that these are the two most important benefits. That's a reason I have mentioned here. If you are working with a system that sends or receive the binary data, ASBITSTREAM function is useful for converting a structured message to a binary format for transmission. Suppose, like example, suppose here there is a source application who is going to send a message into the XML format, but my consumer application can only accept the message into the can only accept the binary data, right? So what we can do, with the help of ASBITSTREAM function, we can convert the XML message into the binary data into the bit stream, and then we'll send to the consumer application. So that's the thing it is saying. So where if it needs to be used, where you are going to where we are working with system where that only accept the binary data, then you can do the with the help of ASBITSTREAM function, you can convert the XML or JSON data into the binary format for the transmission. Now second situation, data storage. When storing a message in a binary format, such as writing to a binary file or database, ASBITSTREAM function convert the data into a more compact or raw format. Okay, that's the same it is saying. When suppose in the same situation that I explained here, where what business is also saying, okay, whatever data you are sending, that's fine. I want to keep a copy of the payload and I want to keep a copy of the uh, error things, so we can keep the error thing and the only into the raw format, or in other way we can say that into the binary format, because it takes some less memory, and that can only be achieved with the help of ASBITSTREAM function. Okay, so that's the two benefits. That's the if the sending and receiving binary data, we can send and receive the binary data, and we can store the binary data. Okay, so if I say in one line, binary data is used to convert any format of message into the bit stream. Point number two, point number one. Point number two, if you want to convert a structured message like XML JSON into the unstructured method, then you can use the ASBITSTREAM function to convert the structured message into the unstructured binary format. Further, if you are thinking your sending or receiving application is expecting some binary data, then you can use the ASBITSTREAM function. Further, if you are thinking like that your where you are the system that you are going to store the data, they're expecting in the form of binary data, then you can use the ASBITSTREAM function to store the data into form of binary data. Okay, now after that, when coming to, let's understand the difference between the binary and the hexadecimal. Many people got confused between the binary and the hexadecimal. Okay, so it is very important to explain the difference between the binary and the hexadecimal. So I have written some few difference between the binary and the hexadecimal, and how basically our ACE application BLOB links with the this binary and hexadecimal. Okay, when talking about the binary, it is the pure raw data stored in binary format. Okay, so it is when talking about whatever data you are sending, when it is actually in raw format, that is called a binary data, which means it is composed of bits of 0 1. So binary data mostly, suppose this is whatever I have written here, whatever I have written here, this is not a raw data. When I will convert this into the 0 1 format, that basically become the raw data. Okay, and that cannot be normally understood by the human eye, because if I will write some lines with the 0 1 0 1 0 1 0 1, so you cannot understand what is 0 1, right? So it cannot be understood by the normal human eye, and we need to use some encoding tool to encode that binary data into the hexadecimal. So with the help of some encoding, basically what we do, we convert the binary data into this hexadecimal format, and further with the help of encoding, we convert this hexadecimal into the back to the original format, into this format. So that's we are going to do. So if I will say a binary data, the data in the form of 0 and 1 is called a binary data, and that cannot be normally understood by the human. Okay, so raw data is stored in binary format, which means it is composed of 0 and 1, often used to store image, audio, video files, or any other data that is not solely textual. Okay, so mostly it is used for the storing a larger file, so the file with the large size like the audio, video, and some PDF file, some other which basically takes some more space. So mostly we use the binary data to store the information into the form of 0 1. Okay, so binary data cannot be directly read by the human or easily viewed without some special tool. It is the typically stored in the by T column in the database like the PostgreSQL. So in our database there is a column with the name with the data type, you can see by T. So with the help, this is the in the event talking about the PostgreSQL, the by T is the basically data type that basically helping us to store the data into the binary data format. Okay, And you can, if you see here, binary data is usually more space efficient than it encoded representation because it is stored as it a raw form. Okay, so when talking about the hexadecimal and the binary data, hexa binary data takes less space or memory in comparison to hexadecimal because binary data is only composed of 0 and 1, and it is the purest and raw form of the message, because the computer can only understand a message in form of 0 1. So when I will basically send this all message to the computer basically converts this all message into the 0 and 1 for, okay, and they interpret this all message, and further when they need to send some output, they basically sends the message into the 0 1 format. And with the help of some tool that is designed into a computer like interpreter, we basically use that converts the computer language into the human readable format, and we basically understand the thing. Okay, so that's the computer can only understand the data in the binary format, that is the 0 1. Okay, and that is the purest and the raw form of the data that we send. Okay, so that's the written, if I say that the binary data is the data that is the raw form of any data. Point number one. Point number two, it is mostly used for the file with larger size, especially the audio, video, or some files. We can use for the text also, there is no problem. Binary data cannot be directly understood by the human because it is only the 0 1. So 0 1 we cannot understand, it is something, it is not understandable, right? Okay, and it basically takes some, when we are going to do store some information in form of binary data, it takes less space, less memory, and that basically save our some uh, storage of the system, storage of database. Now coming to the hexadecimal value. So hexadecimal is a textual representation of binary data using the base 16 number system. Okay, so this data when this data converts into the binary, it basically is stored into database like this. Okay, let me just execute the thing to show you, or let me do the thing. It basically is stored in form of this, and if you want to see this data, you cannot understand this data. Further, what we do, with the help of some encoding tool, we convert this data into binary data into the hexadecimal, so that we can understand what basically we are sending. So you can see what I am writing here. Select encode the column name is the error detail into the hexadecimal format. Okay, and another column name I don't want to do encoding because it is a normal timing from this table. So what I am doing, with the help of some syntax, I am just encoding this column into the hexadecimal format so that we can understand what it is saying. So if I will just execute this line, you can see now it is converted into the some hexadecimal value. And if I will show you, just if I will copy the information to show you, let me just show you. You can see what it is. If you will just understand the thing, if I will, you can see this is the hexadecimal value of what we have inserted into this database into binary format. So whatever we understand, whatever we inserted into database, that is the binary format. Further, with the help of some special syntax that is basically designed in this the post GRESQL tool, with the help of that we converted the binary data into the hexadecimal format. And further, with the help of some plugins in the notepad, we can convert this into the back to the original ASCII format. And this is, you can see, this is the error that actually initially we have got and we have inserted into the binary format. So this is the data that we have inserted into the this table in the form of binary data. Okay, so hexadecimal is the textual representation of binary data using the base 16 number system, useful for displaying the binary data into the human readable format. So it is the it is mainly used so that we can because 01 cannot be understood by the human, so we are basically converting the binary data into a format so that a human can understand it. So you can see what I did. I converted this data. I converted this binary data. This is the hexadecimal. I converted binary data into the hexadecimal value, and further with the help of some tool we can convert back to the normal language to understand it. Okay. Hexadecimal string uses a character 0 to 9 and A to F to represent a binary data. So while converting the binary data to hexadecimal, it uses only a number between 0 to 9 and in alphabet A to F. So if you see here, whatever the value you can see, only it is whatever the you are seeing the letters in the encoded form of hexadecimal, it is only a letter between, in numeric it is between 1 to 9 and 0 to 9, sorry, it is 0 to 9, you can see 0 to 9, and in alphabet between A to F. So hexadecimal string uses a character 0 to 9 and A to F to represent the binary data. So all binary data what we are going to convert into the hexadecimal format, hexadecimal is consist of only a numeric value 0 to 9 and a character A to F. You can see here only those all are showing here, if I can see from my eyes. Okay, now apart from that, you can see each hexadecimal digit represents the 4 binary digit. The binary data of this become this. Here example I have given where I am converting this binary data, this 01 format into the some hexadecimal which including the which is basically between the 0 and 9 and AF. We are using 4D, 61 and 6E. So this is the hexadecimal representation of this is the binary data. So if you see, this is not understandable, at least this is also not understandable, but this can be converted back to the into the original language where what basically stored into the raw form of the binary. Okay, hexadecimal are the largest are larger than the raw binary data, and because the each byte of binary data is represented by the 2 character in the hexadecimal. Okay, so in term of storage, if I said, so if you are going to store some hexadecimal into your database, so it is going to take more space than the binary data. So binary data is the rawest form and it will take less space in comparison to the hexadecimal when we are going to store into the database. Okay, so that's one important point you need to understand when you are going to learn the binary data and the hexadecimal. So if I say the difference between the binary and the hexadecimal, binary is the raw form of any text or image or audio. It consists of 0 and 1 only, and it cannot be read normally by the human eye, by the human, and because it is the 0 1, so 0 1 is something we can see the 0 1, but it is not like that, we cannot interpret it. Okay, and when talking about the hexadecimal has been bring into the picture after the binary to make the binary readable. Okay, so we basically converts the binary into the hexadecimal using the base 16 number system with the help of character 0 to 9 and A to F. So we can, whatever the binary data we are going to represent into the hexadecimal format, that only consists of a character between 0 to 9 and A to F. Okay, so with the help of that hexadecimal we can understand what the binary data exactly we are storing into the database. Now when talking about the ACE, we have the we are not using directly a syntax like blob or hexadecimal. We have a syntax called blob, BLOB, blob. The full form is the binary large object. Blob data is stored in the binary format. Okay, so blob is nothing. Blob is the, as name suggests, binary large object. So it basically, blob is a data type in the ESQL that stores the binary data of any message. So any structured message or any text message, whatever the, or the any uh, form, any format message you can, so that format message can be stored into the blob form, into the binary form with the help of blob data type in the ESQL. And further, blob data can be converted into the hexadecimal for the readability and some other purpose. What are the other purpose? Other purpose can be like that, suppose I want to do some modification, I want to do some converting the blob message into the string, so these all thing can be possible. So to manipulate the message we use the blob. Okay, so binary is the raised for store into 01 format. Further, hexadecimal is used to convert the binary into the hexadecimal format. We convert the binary into the hexadecimal, okay, using the base 16 number system. And the blob is the binary large object, and it is used to store the binary data. And further we can convert the binary into the hexadecimal for the manipulation and the readability. And there can be other purpose that we'll be discussing later, or you can try with that. Okay, so this is all about the binary data, what is binary and what is hexadecimal, and what's the difference between the binary data and the hexadecimal data, and how basically blob link with that binary and the hexadecimal. Okay, now let's move to the syntax of the ASBITSTREAM function. When talking about the syntax of the ASBITSTREAM function, it is consist of ASBITSTREAM, field reference, and these are some options. The thing I have written in the bracket, that can be optional thing. Okay, so either you can mention here or you cannot mention here. Okay, so ASBITSTREAM, field reference, options, you can use encoding, you can use the CCSID, you can use the set, you can use the type with the, and we can use the format. So this, the thing that is showing in the capital letter is the ESQL syntax, and the thing that is shown into the small letter is the value that we are going to provide. Okay, so syntax is like that: ASBITSTREAM function. Field reference is the reference, like suppose if I've been writing the inref declare inref reference to input root.xml. So here inref is the field reference. Okay, options and the option value, encoding syntax and the encoding value, CCSID and the CCSID value, set is the message set and the message set value, type is the message type and the message type value, and the format is the message format and the message format value. Let's quickly learn the all the topic that I have, all the syntax that we have written here. Let's quickly just elaborate, just understand the thing. Okay, field reference, field, what is field reference? A reference to the message tree or the subtree that you want to convert into the bit stream. So here we have to give the reference message, a reference that basically you are going to convert into the bit. You know, the ASBITSTREAM function is used to convert a one format data into the bit stream function, right? So what is the data? Basically it is going to convert into the bit stream that we have to give into the in field reference. The field reference is the reference reference value that we have to give, that you want to convert to a bit stream. And the example I have given like that: suppose when I am declaring a declare inref as a inref declare inref as a reference to input to dot exponency, so here inref is the field reference. Instead of field reference, you can directly write here as a input to dot exponency. So whatever the input message, if you will write here as a input to dot exponency, so whatever the XML message the source is sending, those all message is basically going to convert into the bit stream. Okay, now coming to options. The option specify the additional options for the bit stream generation. Common option includes the in the options value. Common options are the root bit stream and the folder bit stream. Root bit stream basically generates a bit stream similar to what an output node would produce, and the folder bit stream generates a bit stream for the subtree, ensuring the compatibility for the with the folder. Okay, so these are some options you can try with that. You can in your personal laptop, in your personal PC. Okay, when talking about the encoding, encoding value ensure that the encoding value the encoding value to use the bit stream. Okay, encoding value determines the byte order and the numeric representation. Okay, so encoding, when the encoding already I have learned a lot about the encoding, so I don't want to again explain what is encoding. So there are the common encoding values. So these are the two value that's the very popular. 273 is the little Eden encoding, and 546 is the big Eden encoding. So it is just like some in the simple term, if I say that 273 is a encoding that includes some character, not all character, but in 546 is the encoding where it includes almost all the characters. Okay, so that's you can in the simple term you can understand like that. In later you can just try the go on the Google and just try to learn what is the 546 encoding and what is the 273 encoding. Okay, further CCSID, you know, the coded character set identifier, and it is used for the bit stream, and this ensure that the character data is correctly interpreted. You see, this is basically used when we are basically work with the, when we are going to work with the character. Okay, and the common value are the 1208 is the UTF-8 encoding, and the 819 is the Latin 1 encoding, and these two are the most used encoding. Especially the 1208, that is the UTF-8 encoding, is the vast, it used in the is used at the vast level in the IT industry, because this is the one of the uh, encoding that covers all the language. Okay, now talking about set. So set is the telling about the message set identifier. Okay, if you it is applicable, and this specify the message set to be used for the bit stream generation. Okay, type, when talking about the type, is the message type identifier, and this also specify the message type to be used for the bit stream generation. Format is the message format identifier, and this specify also specify that the message format to be used for the bit generation. So if there is some if you want to explore the more thing about the set, and you know already think what is message set, what is message type, message format. Okay, these all are the property of the message. If you see on the when in the logical when the message is in the logical in the debug mode, you will see in the go to the input return property, you will see all the thing, what is the message set, what is the message type, what is the message format, what is the encoding, what is the all thing you can see into the when it will be in the debug mode. Okay, so this is the syntax, and this is the all the options, and this is I will try to elaborate the thing into the very simple language. Okay, now without wasting the time, already I have expended a lots of time into the theory thing, so let's directly go to the toolkit and understand the thing. Okay, if you see here, what I did, I just created a small flow. I have created an application with name ASBITSTream function. Under this application, I have created a message flow name with the ASBITSTream function in ESQL. And in this message flow, I have used one MQ input node and the two MQ output node and the three compute node. This MQ input node I have used to take the input message from the source. Okay, and for that I have used the queue name as a input.queue. Okay, further in the parsing, I have selected the XML parsing to parse only the XML message that's sent by the source. Okay, in complete, I have selected parsing timing as a complete. Okay, to see if any error occurred. Okay, further I am using this compute node. In this compute node, what I did, I just written some code to convert the uh, blob mass to XML message to the bit stream and send to the what I am doing here in this compute node, I am just converting the this XML message into the bit stream. First task I am doing. Second task I am doing, I am inserting that bit stream message into the this database, that is the orders underscore payload. So this compute node is doing three tasks. First task it is doing, it is converting the bit stream XML message into the bit stream. Second task it is doing, it is converting the it is sending a copy of message of the XML message into the whatever the input message it is coming, it is sending to the output. Third task it is doing, it is converting a what is it is inserting the bit stream message into the table known as order underscore payload. And further it is we are also converting the bit stream message into a string and also storing under a string variable. Further, with the help of capture error node, we are basically capturing the error. With the help of exception handling, what I am doing here, I am just sending a copy of error to the output, and also I am inserting the I am converting the error message into the bit stream and inserting into the this database as error db. Okay, so I have already created two database. To create database, I have used a simple, you can try with that because I don't want to show, but I can try. I will, let me show you, because you can create a simple table with the create table, not here like that, here it is. Okay, so create table and the table name, this is the as error db. I use the table column name as the error underscore detail with type this will vary from the system to system, but if you are using the PostgreSQL, it will be the for blob. If you want to specify a data type as a blob, then you have to use by ta. This is another column name I have mentioned here, the error occur time, and the timestamp I am using as a current timestamp. Okay, so you can see it's the same. You can see here there are two column are there. If you browse this is, you can see there is a one error detail, another is the error occur time. So these are the two column error occur and with the type by ta, and then another is the column with the error occur time with the time stamp without time zone. Okay, because I have not mentioned any time zone, so it will take my by default from this pc. Okay, and for me it is the in the ist timing. Okay, so this is the that with the help of this I created a error table. Now, with the help of this syntax, I have created a table for the payload. So I created with the help of create table, I created a table name with the order underscore payload. So I am creating a table with the name order underscore payload. Let me just show you also here. And if you see, you can see there is a table with the one column name as a payload and other is the payload insert timing, and it is of type by ta, and it is time stamp without time zone, so it will take by default my time zone. My time zone is the ist time. Okay, so So it is the one column name I have sent mentioned here, the column name and the type, and another column name and the time as a timestamp with the default current timestamp. Okay. Further, I have used some select query to select the data from the database. Okay. So these are some other, you can see there are three select queries there. So these all having some specific use. Okay. Suppose if you see here, if I am writing this into the normal this format, I'm using select a star from this s error db. So it is just showing the what we have inserted. It is showing the when my data has been inserted and what is the what data has been inserted, and it is into the when it is inserted. But I cannot read these all data because this is the binary data and this cannot be read by the human. So I am just seeing that there are some binary data has been inserted, but and when it is inserted, but I am not able to see the data. But there are some syntax that actually available in the PostgreSQL. With the help of that, we can read these all binary data. Suppose if I want to convert these binary data into the hexadecimal, then we can write this syntax like that: select encode. I am doing encoding. Encode what value what column I want to encode. I want to encode this error detail. So I am just mentioning the column name. What is the encoding I am used to? I want to encode this value into the hexadecimal format. So I am using hex and another comma and another column name. I'm mentioning here the error detail timing, and from which table I want to do encoding. So this table. Okay. So what I'm select encode bracket column name to which I am going to do encoding. And what encoding I am going to do? I am going to convert the value binary data into the hexadecimal format. And another column name basically I want to also select. And from the table, so I am just using this. So if I will execute this line, see what basically it is looking. You can see now it is looking into the binary format. So into the hexadecimal format. So you can see there is one column is showing into the text format, and you can see it is showing as an encode because I am using encoding here, because it is the encoded form of the value. And you can see this is the encoding here, and if you go at the right side, you will see the another column with the uh, error occur time. So we have the two column, this column with the value hexadecimal format and this column with the when it is inserted. So now it is looking more readable, right? Further, there is also a syntax in the that supported into the PostgreSQL. With the help of that, we can make this binary data directly convertible into the uh, XML format, into string format, right? So with the help of UTF-8, you know the UTF-8 is the CCSID 1208. Okay, that basically includes all the uh, character, and it is especially used for the character encoding. So instead of hex, I can, if I will mention in UTF-8, this basically converts directly binary data into the human readable format. So if you see, if I will execute this, you can see now it is looking more good, and it is with now I am directly able to read the thing, right? So with the help of, if I will write like that, convert from, okay, error detail. So you can write here anything. Suppose I have written here something, convert from, okay. If I will write something like that, let me write here as error detail, okay. Okay, and let me, okay, okay, some, I think the convert from is this, there is some syntax, okay, so we cannot do modification. I was thinking we can do modification, but we cannot do, okay. So this is something, convert from is a syntax that basically supports by the PostgreSQL, okay. So I was thinking this is not a syntax, but this is a syntax, okay. So convert from is the we are basically with the help of convert from, we are basically converting the column that is basically into form of binary to directly to the UTF-8, which UTF-8 is basically a text format. Now you can see we are able to read these all into the text format, right? And we are seeing the second when it is inserted. So this is how basically we are going to, I am going to show you how by inserting the data into the column, and I am going to show you both case when I will be inserting the payload, and second case when I will be inserting the uh, okay, when I will be inserting the, what I say, that error detail. Before that, let me do one thing. Let me truncate the table, because I don't want to show, I don't want to keep anything for now. I want to show you from scratch. Okay, let me truncate it. Truncate and the table name. So let me do. So now table has truncated, and if I will further do select a star, you can see there is no detail. Now let me truncate this table also. So it has also completed. Now let me just select this also to see if any data left or not. I don't think it is left, but still it is better to check. Okay, now you can see neither s error db having some data, and neither order underscore payload having some data. So I have erased the column. With the help of truncate, we can truncate the column. It means we can clear all data from the column. Okay, so I have truncated the table. Now let me remove this syntax. Okay, now let's go to the ACE toolkit, and let's implement the code, and let's see basically how can we achieve the target. Okay, so now let's take the first situation where the error is occurring. I will be covering in two way. First I will be covering this thing situation, and secondly I will be covering this situation. Okay, okay, so in first situation where the failure situation is happening, then how basically we are interpreting the thing, and secondly when the successful is happening, when how basically we are interpreting the thing. Okay, now suppose when the system source is, I'm using this message for, I'm using this message as a input message for sending to the business. So this is the simple message with the order XML message with the order ID, with the some order ID and some customer name and the quantity, total price and the delivery address and the mobile number. Okay, so this is the normal message I am using, where I am inserting the detail into the database. Okay, okay, so now let's take a situation. I sent this message, but this message having some not proper XML, and it's throw the error, and it goes to the failure node. And so how can we achieve the thing where I will be sending a copy of XML error XML message to MQ output to the queue error.q, and how can we insert the error detail to the this database, that is the ACE error db. Okay, correct. Now let's do one thing. Let's see what I have written here. First, what I am doing here, I am doing simple thing. I am fetching the error detail. I am writing here a set output root dot xmlnsc dot error detail. So I in output root I am creating a field called xmlnsc. Also under xmlnsc I am creating a field called error detail. Under that I am storing the error occurred. So I am storing the exception history. From exception history, what error occurred, we are just storing the information under the output root. So in the output root, I am under XML NSC, I am just creating a field called error detail. In error detail, with the help of input exception list, I am taking the I am just capturing the information from the exception list regenerated and sending to output. So you know that the output what we have sent from this node is the input for this node, right? So when I will be just sending the output to this, it will become input for this node, correct? So with the help of input root dot xml nsc dot error detail, same error detail can be same error detail can be accessed. So here what I am doing here, I am just capturing the error detail and sending to output. So with the help of set output root dot xml nsc dot error detail, I am just storing the error occurred from the exception history under the error detail and sending to the this output. And when it will came here, it will become input for this compute node. So if same information I need to access here, then I will be using the input root dot xml dot error detail. Okay, the same thing I have written here. First, I am doing two tasks. I am creating a blob payload for database. Not I can directly write blob. It I can write. I am creating the bit stream. Bit stream. I'm creating the bit stream payload for database and inserting database. And second task I'm doing, I'm just using the sending a copying of error detail to the output, so that the support people working in the project can check it. So two tasks I am doing. I'm just creating a bit stream message, binary data stream message, inserting in database, and sending a copy of XML message to output. For that, what I did, I declared a variable with name error underscore log, which is of blob data type. Blob is the binary large object. So I created a variable with variable name error underscore log, which is of blob data type. Further, I declared a reference variable. We declare error underscore log, error log underscore field reference. It is same like that inref. Reference to input root dot xml dot error detail. So this is nothing. This is what we have sent to output. So what we have sent to output, what I am doing, with the help of reference variable, I am capturing this. I'm capturing this to I'm capturing to this node with the help of input root. So with the help of input root dot xml dot error detail, I am getting the error detail and I'm storing under the this reference variable. So under this reference variable, I am just storing the error detail. Okay. Further, with the help of set command, okay, I am just under the blob variable, with the help of ASBITSTREAM function and the reference variable I am using, I am converting the XML error detail in message into the blob format. So here what I am doing, here I am converting the XML error details to binary. Okay. Further, I am inserting in database. For that, I am using insert into database, database name, column, first column name and the second column name, values and corresponding the value. The corresponding for error detail, it is the binary data. So we will be using the error underscore log. Error underscore is the, this is the binary data, and the current timestamp is the my local timestamp with the PC. Further, I am doing simple command. I am set output to .xml equal to reference variable. So whatever the value we stored under the reference variable, I'm just sending to output, and the under the reference variable I have stored the error detail. So I am doing the, I am creating the variable blob, declaring, so not create, declaring variable, declaring the variable blob here under the reference variable, storing the error under the reference variable. So with the help of declare variable name and data type, I am just declaring a blob variable, and blob variable is a variable that can store the binary data, that can store the bit stream data. Further, with the help of declare field reference to, I am referencing to the input to .xml detail. From here, I am basically accessing the error exception detail and storing the error under the reference variable. Further, with the help of set syntax, under the blob variable, I am converting the reference to the bit stream. So with the help of ASBITSTREAM function and the reference variable, I am just converting the XML error detail to the binary. Further, with the help of insert, I am just inserting the whatever the value we stored under the blob variable, and the timestamp I am giving to for the current timestamp. And you know the reference variable is storing the error detail. So in output, I'm just sending directly the reference variable to send the data to output. Now let's see how basically it is working into debug mode. So let me first create a bar file with the name ASBITSTREAM function. If is means, just click on finish, select the application and build and save. Now let me, currently there is no application deployed. Now let me deploy it. Now you can see it is deployed. Now let me launch the debugger. Debugger is launched. Let me edit the message with the wrong XML format. So I just I just in tag I have just removed that, so that it will be not a proper XML format, and now it will be, that's reason it will throw error. Okay, now let me hit the flow. So let me just select the queue already selected. Let me just select the message is this one. So I just selected a XML message. You can see it is giving the error also in XML because it is not in proper XML format. Now let me hit the flow executed, you can see. And here you can see under the XML message, you can see I am sending a message in order detail. Only order ID is coming because from here customer name is not in the proper XML format. So that's then it is not further populating the tree. And here you can see exception has been generated. Under the exception list tree, exception generated. And if you just, I will copy the information to show you. If I will copy the information to show you, you can see what error is giving. So in tag of the element type customer must be a this. So it is saying that the customer has not a int tag this. So customer has a missing int tag this. Okay. So this is the int tag that is currently missing to customer. It is saying that. Okay. So now this is the error. This is the currently error populated, and this error is a populated in form of tree. You can see here it is populated in form of tree. Further, with the help of compute node, I will be just sending this detail to the output root. Currently in the output root there is no detail. So let me go inside the compute node. In compute node currently, if you see under output root, there is no data has been stored, and I will be going to store this exception detail into this output root. With the help of output root, and I am going to create a field explainc. Under it I am going to create a field error detail. Under that I am going to store the this exception detail. From parser it will be going to store. So let me execute this. After executing, you can see under output root a field called explainc created. Under that a field called error detail created. Under that a field called parser exception has been created, and all the thing error what you can see the same parser exception and the same thing you can see is showing into output. With the help of return true, I will be sending this output message to the output. Once I will be send this message to output, it will become input for the next node. So you can see when I will send this message here, this message will be input for this node. So whatever the output I sent here, it will become input for this node. You can see in the input now it is showing the XML error detail and the parser detail. So all error detail is showing into the input. Now let's go inside the exception handling. Currently you can see there is no blob variable declared. Let me declare a blob variable. You can see a variable has been declared which is of blob data type. Further you can see there is no reference variable has been declared with the error log underscore field reference. I will be going to declare a field reference which is going to refer to a field called input root.explainc.error detail. And if you go, this is the input root. Under that we have the explainc. Under that we have the error detail, correct? And under error detail we have the exception, parser exception. So this parser exception what we are seeing here, this information. So now my field reference is directly refer to is going to refer to this parser exception. So till our my field reference is directly referring to input root explainc and error detail. So my input root explainc error detail will be replaced with the field reference. So it will be under field reference we are going to see the parser exception, these all detail. So let me just move forward. You can see a field reference with the name error log under field reference is created, and under it we are seeing a parser exception and all the error detail. Okay. Now further what I am doing with the help of set command for the variable error log which is a blob data type, and with the help of function ASBITSTREAM function, whatever the value we have stored under the field reference, this is actually a tree, and in simple word if I say that this is a XML message. So this message I am converting it into form of binary. So with the help of ASBITSTREAM function and the field, whatever the field reference I am providing under the ASBITSTREAM function, it will convert this whole information into what I said it into the binary stream, or you can say that bit stream. and I am going to store these all, whatever the information it is going to return after the converting into the binary data. I am going to store under the error log blob variable. So let me execute the thing. You can see after executing against a blob variable, we are seeing some value, but the blob binary message cannot be readable because it is a combination of 0 1. That's the reason there is a specialty in the toolkit. What it for our understanding, it basically, and also for the further manipulations, it converts the binary data into the hexadecimal value. So this is nothing. This is the if I will copy the information and if I will paste here to show you, and if I will further convert this into the back to the ASCII, you can see this is nothing. This is the similar to what we have here. Okay, but the one point, if you see, this is not in the exact format that it is showing here. This is the actually the XML type of format where it is in the tree format, not the XML, it is in the tree format. But if you see here, it is in the string format. It is showing into one line. This, although this is the XML, this is a valid XML, but this can be stored as a tree. We cannot store this message as a string, but we can store this message as a string. I will be showing you later, don't worry. Okay, now further, so what I did, I just, with the help of set command, I just stored a binary data into the blob variable. So I, for the blob variable, with the help of ASBITSTREAM function, I converted the field reference to the bit stream, and I stored under the blob variable. Further, with the help of insert syntax, I am going to insert into the database as error db. We having the two table error details and error occur time, and I am going to insert into the this error log, and error log is nothing. Error log is the this value that is showing here, and with the help of current timestamp, current timestamp is the timestamp currently the IST time that I'm just recording the video. Okay, so if I will insert this, let me show you. Before that, currently if you see under the as error db, there is no value, right? Let's execute the syntax. It executed and insert has successful, but it still it will not show because the transaction has not completed. Further, what I am doing, in the output route, I'm just sending in, I want to send a copy of error detail to this further MQ output. For that reason, I am just in the output route, you can see under the output route currently there is no value present. In the output, I am creating a field called XML and under XML I am just storing the whole error detail. I'm just using the reference, this reference. Instead of that, you can write also as a you can write directly this as a input root.xml error detail. That will also work. But what I'm doing, that as this is directly representing this field reference, so I am just directly using the field reference to send this information to output. So if I will move forward, you can see in the output route, the whole error has been stored, it has been setted. Okay, in output route we are sending. Further, if I will move forward, you can see in MQ output we are getting the exception detail because the output for this is the input for this node. Further, if I will browse the output queue, let me first browse the output queue to see if any message is previously present. So this is the error queue, and currently there is one message. So let me clear the message. Okay, so currently there is no message. Now let me complete the flow. Now flow has been completed. Let's see first database. In database, if I will execute thing, you can see one record is showing, and the same record you can see we have the binary data and when the error occurred. The error has occurred on 18th January 2025 at around 8:46 p.m. And if you want to further see what exactly into the hexadecimal format, so you can just convert this into the hexadecimal. So this is the hexadecimal format converted, and you can, with the both column it is showing here, it is the timestamp when it is occurred. And further, if you want to just only if you want to copy the information, you can copy from here, and you can further, with the help of notepad, you can do also conversion. That's no problem. You convert what I written, just 1 minute. You need to do something like that. Just you need to, okay, you can do convert, select the, and you can see the same thing what we are expecting. This is the same. Okay, further you can see from here else also, if you execute this thing, it will show you exact error detail into the text format. You can see the same error detail, it is now inserted into database with the timestamp. Further, if you browse the output queue also, you can see the output queue also one message. And if you see the error, it is the same error showing where the information is about the customer detail is not correct. Okay, so in this way we can perform the operation with the inserting the data into database, and also into the sending copy into the output. Let me try to send one more message with some different wrong information. Suppose this time let me modify the customer with the correct detail, and let me modify the mobile number. Okay, now let me send the information. Written the information to the queue, it came here. First error has occurred. Go inside the compute node. I just capture the information from the input exception tree and send to the output. In output it came as a input for this node. Further, in this node I declared the blob variable. I just declared the field reference. I converted the field reference to bitstream, inserted it into database, and send to output, and just return true. Done. Now let's go to the database. Just select the table. You can see now two data is showing. Another data has been inserted at around 8:56 p.m. after the 10 minute. And if you see further, if you want to see it into the form of here, you can see the same detail in form of hexadecimal. And further, if you want to see the same detail in form of text, you can see it in form of text also. And if you see the error detail, you can see the error detail. You can see it is coming something like mobile number. If I will copy the information to show you, let me copy the information. Okay, you can see if I will do like that, you can see it is saying that exception occurred with some mobile number. The int tag of the element of mobile number must be ended with the f'. Okay, so it is coming like that. Okay, and if you see, browse the output queue having also error detail, and it is giving the same information. Correct. So in this way we have seen how basically we can capture the error detail. We can send a copy of error detail to output also, and we can store the error detail into the database into the bitstream format. Okay, now this is the first part covered successfully. Now let's come to the second part, where the successful scenario is happening. And what I am doing, I am just copying a payload of a copy of payload, and just sending to the output and inserting database also. Now let's go inside this compute node. This compute node, I am doing few of the tasks. First task I am doing, I am taking the input payload and inserting the payload in database. Second task I am doing, I am just sending a copy of payload to output. Okay. And third task I am converting the XML message to string and storing under the string variable into the character. So we cannot directly convert this XML message to the string. See, if someone is saying to you to convert this XML message or any other XML message, suppose this XML message to string format, so you cannot directly convert the uh, XML message to the string format. For that, what approach you need to follow? You need to first convert the XML message to the BLOB, and further with the help of cast function you can convert the BLOB message into the string, and you can store under the character variable in the ESQL. So let me show you everything and let me explain you everything. First, what I am doing, I am just declaring a variable with name orders underscore blob, which is a blob data type. With the help of field reference, whatever the all message I am sending into the input is with the help of input to.xml I am just capturing whole detail, and with the help of set command I am converting the XML message to the bit stream. So with the help of ASBITSTREAM function, I am using the field reference. Here I am using the encoding and I am using the CCSID. So here it is very important to use the encoding and the CCSID. To use the encoding, what you have to do, you have to write the field reference, comma, input root dot properties dot encoding and the input root dot properties dot CCSID. Okay. So this will take the from the input message property it will take the encoding, and from the input message property it will take the CCSID. And further I am inserting into database with two column. If you see this table, that the payload table, this payload table. So this payload table has two column, payload and the payload insert time. So this there is two table column is showing payload insert time, and I am inserting the bit stream, that is the blob variable, and the current time stream. Further, with the help of output root, whatever the message, either I can write here as a field reference, that is also fine. Okay. So instead of writing this output root explanation, I can write here the field reference, that will also work. Okay. Now further I am declaring a variable called character, and I am for the character variable I am just casting the blob to the character, and I am using CCSID as a 1208 as a UTF-8. If I will not use 1208, it will not convert it. But let me first remove it and to show you. Let me build save the bar file. And let me deploy it. Now let me hit the flow. Now message is correct. Now let me open the message and write it. Flow executed. Message came to output. This time it is successful. And if you see into the input, we have the input root under XML. We have the orders. Under order we have the order ID, customer name, quantity, price, these are mobile number. Okay. Let's go inside the compute node. In compute node, first I am declaring a variable name orders underscore blob, which is a blob data type. So it is declared, you can see. Further, I am creating a field with the name, I am creating a field reference with the name field reference, which is of reference data type. And it is pointing directly to the input message, that is the input root.excellency. It will directly under the field reference, this whole information it is going to store. Okay, so you can see and field reference is created. Under field reference, this whole order detail is stored. Okay, further, with the help of set syntax, I am just setting the value against the blob variable and blob data type, sorry, blob data type. So I am setting value against the blob data type, and with the help of ASBITSTREAM function, I am converting the whatever the value present under the field reference. Okay, this whole information, this whole XML message. Further, I am using the encoding and CCSID. If you go to the input message, you can see when you will send the input message, IBM has some by default encoding and CCSID text it. Okay, so you can see this is message called input message, right? Under input root, if you go to the properties, under properties you can see we have an option called a message set, message type, message format, encoding value by default is 546, CCSID by default value is 437. So currently it will take by default value. Here it will be replaced with the it will replace the value with the 546. It will take from the input root dot properties dot encoding, and it will take the value 546. Similarly, here it input root dot encoding dot CCSID, and it will take input root dot property dot CCSID, and it will take the CCSID value as a 437. Okay. Further, if you want to use some other value, then what you can do, either you can specify, you can set the property, you can set the property manually with the help of some ESQL code like set output root dot properties dot CCSID, something like that. Okay, or you can ask the business to send the CCSID information into the input message. So when the business will send the encoding information and the CCSID, it will populate here. Currently I am using the RFHutil, so it will taking the by default thing. Okay, so if you go to RFHutil also, if you go to the, I don't think it in the, it is in the property section, something like that. Anyway, so it is taking the by default value as a 546 and the CCSID 437. Okay, and if you see here how I have explained the things, so these are BitStream has supporting various things like the field reference is the value that basically we are going to convert into the BitStream. Further, we have the option, we have the encoding. Encoding is the same thing that it is showing here. This is this one encoding. CCSID is the same thing that is showing here, and the value against it, you can see the value encoding and the value against it, CCSID value against it, and the further if you see here there are many other options like that. The set is the message set, and you can see this is the same thing that it is showing a message set. So if there is value against it, it will take it. Further, we have the you can see message type and the message format. So here you can see the message type and the message format. So these all are the property of message, and these all property, either you can set the value or manually with the help of some ESQL code, or it will take the value from the property if we use the property in the while doing the using the ASBITSTREAM function. Currently I am using the only two this value, that encoding 546 and the CCSID 437. That's it, it will taking. So it will take the encoding value as a 546 and CCSID 437, and it will convert the this input message into the string format, and it will store under the order underscore blob. Okay, so let me move forward. You can see under the order underscore blob, the value has been stored into form of binary, but it is showing as a blob. Region is that it is showing as a hexadecimal because it is due to region. It we can understand the thing, and you can see the same information that I am sending to input, right? Same information. So so it is converted into the binary format, but it is showing here as a hexadecimal because we can understand the thing and we can do further manipulation if required. Okay, with the help of insert command, I am inserting database, and I am taking the value for the payload as a this whatever this thing showing under the order underscore blob variable, so into data type, and the timestamp. Now you can see that has been inserted with the help of output true.explanancy. I am taking the value whatever the value present under the this and sending to output. So currently if you see in output there is no value present. Now I am just sending to the output. Okay, further with the help of declare, I am declaring a field name and declaring a, just 1 minute. Okay, so I am so I am declaring a variable with which is a character type. So you can see declared a variable with order string character type, and further with the cast I am converting this variable to the character. But if you see here, it is not converted to character format, right? The reason is that you can see it is still showing into the hexadecimal value. It is not showing into the character format. The reason is that I have not used the encoding. If I will use the encoding, and if I will use the CCSID, it will show into the proper format. Okay, so that's the thing. If I will further move forward, you can see the same value we can see into output. In if you browse the output queue, let me just browse the output queue. So this is the output queue. Let me browse the latest message. Okay, this is the latest message. You can see the same message that I am sending. Okay, and if you will browse the payload queue also, you can see one data has been inserted, but data it is in form of binary data, so we cannot understand. So with the help of encoding, we can convert into the some hexadecimal value, and further if you want, you can convert this into the from what I said in the some let me do here. You can convert it into the form of text format with the help of this syntax. Now you can see it is the same swing, right? Let's keep this for here, right? Let me just keep the hexadecimal for now, and if I will copy the same information, let me show you what it is getting inserted. And if I will remove this thing, and if I will convert this to show you, you can see the same information, right? So with the help of this same thing, we can what we are saying with the you can see now we have successfully inserted data into database, and we have successfully sent a copy into the output. Okay, now let me modify the flow. First, I have faced a challenge where I am not getting exactly the string. To get a string, you can use the CCSID. CCSID 1208 is the for the text that cover the all string. Further, if you want to use the encoding, you can use the encoding also. There is no restriction of using encoding. Suppose I want to use the encoding also. So you can use the encoding, and you can take the encoding default value from the what I said it from the input message. So this can be written also like that. So like what I'm doing, I'm just whatever the blob message was there, I'm with the help of cast function I'm converting to character. Further, I'm using the CCSID 1208, which is the UTF-8 for the encoding, and further I am using the encoding value from the uh, message property. Whatever the message it is coming into property, I am taking the value. Okay. This line, what I did here, can be written into some other way also. So let's try to write this into some other way. This can be written in some other way like that. Let me just remove the thing. It can be written like that also, CCSID, and you can specify the default value, and also you can mention the encoding, right? We need encoding and value, encoding value. So in this way, okay. So it is giving error. What error is giving? Okay, it is coming order this. Okay, let me try to do something like that. Let me just remove this thing and let me place after this. Okay. Okay, here comma is not required. Okay, I was giving the comma, that's the reason we are giving the error. Let me do one thing. What is the wrong happening? Let me just say field reference encoding and the encoding value, then CCSID and the CCSID value. Okay, that's fine. So this is the syntax. So set, I'm setting value against the blob variable with the ASBITSTREAM function. I am using the field reference. I am using encoding syntax. Against that, I am setting the value from the default property of message. I am using CCSID. I am setting the value from default property of message. Okay. Now let me build and save bar file and let me show you. Now deployed successfully. Now let me hit the flow. Now it came here, coincide compute node, declared the blob variable, declared the field reference. With the help of, you can see, currently I am using the set blob var ASBITSTREAM function. The field reference is the value against that the order XML message. I am using encoding. Against encoding, I am assigning a value from the this input root dot property dot encoding. So what I am doing, I am using here as a value as a 546. Similarly, CCSID, and I am using value from the input message, that is the input root XML. See that 443. Why I am using like that? Why I am not assigning value directly value here like that? Why I am not assigning value directly as 546, and why I am not assigning directly value as a here as a 436? We can do the same thing. I will be showing you that thing also. But the main benefit of using this thing is that suppose there is a source application, and source application is saying that I will be using the encoding value as a I will be myself sending the encoding value, and that encoding value you have to use. You don't need to take care about the encoding thing. So when they will send a message, they will send the this encoding value. This they will be going to send this encoding value. Okay, and we are going with the help of input to dot properties encoding, we will take their encoding. With the help of input to properties CCSID, we will take their CCSID. Okay, so that's the reason we basically use the input root property or CCSID input root property encoding. Okay, now let's move forward. Now after that, I'm inserting to database. sending to the output, declaring the field reference, declaring the string variable, character variable. Further, with the help of, now you can see what I am doing here. I am using cast. I am casting to character. Similar thing you can see what I am using CCSID, and this time I am not using the by default property. You can see here I am using manually giving the value as a 1208, that is the UTF-8 encoding, and further encoding value I am taking from the this directly, this 546. Okay, so what is encoding value? Let me just write here 546. Okay, now let me do. Now you can see this time against this string, this is stored into text format. Now if I will copy this information, you can see the same information, right? It is showing slash because of the next line. Okay, so don't need to worry. Okay, so you can see against the string variable, against the character variable, we are basically storing the string. So now we are storing the payload in form of string, right? So we achieved three things. First thing, we converted the XML message to the blob. Second thing, we inserted that blob message, binary message into the database. Third thing, I send a copy of blob XML message, normal XML message to output for the further business to use it. Fourth message, I converted the normal XML message to the string message, and to convert the normal XML message, this XML message to string message, this XML message to string message, we cannot directly convert into string. What we have to follow, we have to convert the XML to the blob and further blob to the string. Same thing you can see here, it is already converted into blob, so I am just casting the blob to the character, and I am using CCSID and encoding value. Okay, further let's move forward, and you can see it has been, if you go to database and if you will select this thing, you can see one more record has been inserted, and if you will just copy the information, you are going to see this, you see the same information. If I will convert to hack ASCII, you can see the same information, right? And if you go to output queue also, if I will clear the first queue, first message, you can see the same information, right? So in this way we can use the ASBITSTREAM function to do some encoding thing with the help of. Now let's do one thing. As we know that CCSID is the one of the important thing when we are learning the encoding. With the help of CCSID number, it basically tells the which basically language it is going to, which character it is going to allow. And you know that 1208 is the only character CCSID that basically allowing the all character, right? So now if we are not sure which basically character format the source is going to send a message, then what we can do, instead of mentioning here as a CCSID default value from the source, we can mention here as a 1208. And if you not sure about the encoding value, what encoding value business is going to send, you can mention here it is the 546, which is the big hidden, little hidden value is 273, which basically consists of some short range. But if you mention 546, which basically covers almost all characters, so if you mention 546 instead of that, if instead of that 546, okay, so it will basically cover wide range and you don't need to worry. So now if I will send if I will send further a Chinese character, suppose I want to Chinese some name. Suppose I want to use some Chinese name. Mm, suppose some Chinese, let me suppose this Chinese character. Okay, so this will basically going to allow us also. So if I will just, instead of my name, I will write some Chinese name here. So this is not going to throw error. Not here, I need to mention into option. Okay, so this is not going to throw an error because one, the CCSID 1208 covers the that range also. So if I will build and say the var file, and further, and here also if you want to mention the encoding 546, so you can, instead of mentioning by default, you can mention here as a 546. And if in, let me build and say the var file, not deploy, first build save. And let me deploy the var file. And let me first, let me hit the flow executed. It came here. You can see currently the input. Okay, it is showing Risutivar itself because I have not loaded the message, I think. So let me load the message. Okay, now this time you can see currently it is not showing it. If you go here, you can see name is something like that, right? It is some Chinese character. If I will write the message, you can see currently the customer name is showing like that. This is something I cannot understand. Okay, don't worry, but computer will understand. Okay, so if I will go further inside compute node, I declare the blob variable, declare the field reference. With the help of, you can see further we can convert this XML message into the blob, into bit stream, and there will be no issue happen because here we are using encoding as a 546 and the CCID 1208, and 1208 covers the wide range. It covers the almost all the language. Okay, so if I will move forward, you can see under the blob the value has been stored. And if I will copy and show you, if I will further want to show you, you can see if I will convert this to the ASCII, you can see the same information. Customer name, same thing is showing. It is although showing into the string form, it is showing into one line, but you can see the same information. Okay, now further with the help of insert, I can insert into this into database also, and with the help of output route I can send this to output also, and with the help of order string I will be going to create a string and I will be sending this to output also. You can see the same thing in output. If I will just do like that, you can see the same thing in output also, correct? If I will copy this, let me try to copy it. Okay, if I will copy this, whatever I send to the, I set it and the character here, you can see the same thing. Okay, now if I will just further, I will do return true, it will go outside, and if will return. Now let's browse the database. You can see this is the, I think this fourth is the latest information that I inserted. I think this is one. Okay, you can see if I will copy this information, let me just copy the information. If I will copy this information, and if I will show you, you can see the same value has been inserted in database without any error. And if I will show you to output queue also, let me browse the latest message. You can see the same information with some Chinese character. Okay, so in this way we have seen any type of character is now my AS application is parsing without any issue. Okay, so this is the importance of using the encoding and CCSID. Okay, this all cannot be achieved without the encoding and CCSID. Okay, so that's the reason I already thought to explain you what is encoding and what is CCSID before going into deep dive before going to deep dive into the ESQL things. Okay, now I think I have covered almost thing whatever it is required for the uh, normal people to understand the ASBIT stream function and the encoding and the CCSID. I will be taking 2 minutes just to uh, cover what to explain what I have covered. First, I have started with the ASBIT function. First, I have covered the encoding. In encoding, we have seen it is used to convert one format to other format, and we have seen the types of encoding: the ASCII, UTF-8, and the base64, and the URL encoding. Further, we have seen the CCSID and different CCSID value we have seen, that is 273, 819, 1208, and 1208 is the most important one that basically cover the wide range of character. It is called covered almost all character. Further, we have seen the difference between the binary and the hexadecimal. We have seen that we use the hexadecimal to convert the binary. Okay, and further we have seen the what is blob. Blob is the basically a data type, basically a variable. We store the binary data, and it is the hexadecimal also representation. Okay, and further we have seen the syntax of the ASBIT function. In the further we have seen the our the ESQL. What basically we did, we cover this into the two way. First, what if error occurred, then in error occurred we have seen the we have captured the error detail, and further with the help of ASBIT stream function, I basically converted the error message into the bit stream and inserted in database, and also sent a copy message to the output for the further checking. Okay, further in case of successful happening, what I am doing, I am just converting a input message into the bit stream with the help of ASBIT function with some encoding value and the CCSID, and further I am inserting this into database. Further, I am sending a copy of input message to output also for the business needs, and also what I am doing, I am converting the XML message into the string format for the further uh, 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 transformation and further needs by the business and further requirement. Okay, this all we have learnt into, I have tried to explain into the very simple and the crystal language. Okay, so I hope you have enjoyed this lesson, and I don't think you have any doubt. But still, if you have any doubt and question, you can reach out to me. And if you want to connect me, you can reach out to me over the mail, my learn and pass official. Thank you all.